Okay, so in class we've been talking about logs and how they work and when we would use them. And what I want you to get into your notes right now are the rules for expanding logs, because it's really important that you understand these rules. Here's the catch. If you know the rules for exponents, then you actually already know the rules for logs. Because keep in mind what I told you, when you're finding the log of a number, you're actually finding the exponent on that base. So if I had something like log base 4 of, I don't know, we'll do something simple like 64 equals x. When I'm finding the log of 64 in base 4, what I'm looking for is the exponent on base 4 that will actually give me an answer of 64. So because of that, because logs are really exponents, keep in mind that the rules for exponents then become the rules for logs. Okay, the first rule is the product rule. If you have the product of two numbers and you want to take the log of that product, and we'll call the two numbers x and y for now to keep it general, I will tell you that that is equal to the log of x plus the log of y. So logs takes product and turns it into addition. The second rule is the division rule. And the division rule says if I have the log of the quotient of two numbers, x divided by y, that this is the same as taking the log of x minus the log of y. And the third rule, the final rule, is the power rule, which says if I have the log of some base raised to a power, then that's going to be equal to the exponent, y, or the power, times the log of the base. So it's really like this. Okay. And those are your three rules. So what I want to do is just put a few examples in your notes, and we're going to be working on this more in class. So, and the explanation behind why these rules for logs follow the rules for exponents is also going to happen in class. So let's say I ask you to take the log of x times y divided by z. Okay, so what I have going on here is a product of x times y and a division. So when I expand this through logs, this is going to become the log of the x, first term is x, the multiplication will turn into addition on the log of the y, and then the division will turn into subtraction of the log of z. And that's how we expand that. And that's really one of the tasks that you're going to be asked to do, is to simply write the log of the expansion. Okay, so let me give you a different example. Let's say it looks like this. The log of x squared y cubed. So when I take this, now again, what I have here is a product. So there's two terms, and each of these terms is raised to a power. And so basically what's happening is this power of 2 says I have two bases. And so when I take the log, there's going to be 2 log of x's, because there's 2 factors of x, plus comes from the multiplication, there's going to be 3 log of y's. And that's the expansion on that one. Now what you want to also understand is that when you have radicals, like let's say I ask you to take the log of the square root of x divided by y, what we tend to do is think of the square root of x as x to the 1/2 power. It's a little bit easier to do the log that way. So if I think of it that way, I'm going to rewrite this as the log of x to the 1/2 power divided by y. Now, for the power, whether it's fractional, which means it comes from a root, or it's not, whether it's an integer, it follows the same rule. So when I take the log expansion, this exponent will come down as a multiplier on the log of x, and then I will subtract the log of y. So again, it doesn't matter if your exponent is a whole number, like the 2 or the 3, or if it comes from the radical, like the 1/2. Okay, you don't have to rewrite it as x to the 1/2, but I just wanted to show you where that 1/2 came from. Let's just do one more. If I take, the log of, let's see, I'm going to do x squared y divided by the square root of ab. Okay, so when I take this expansion, I have several things going on here. I have two terms in my numerator that are multiplied together. One has a power. In my denominator, I have a single square root, but in that square root, there's a product. So let's break it down one piece at a time. First, I'm going to take care of the numerator. And again, I have two factors of x, so I'm going to have twice the log of x. The multiplication becomes addition times the log of y. Then I'm going to subtract, because that's from the division. Now, in the denominator, I'm going to put this in parentheses, because I don't want, I want to keep all that stuff together. The whole thing is under the radical. So that means I'm going to have a 1/2 times. Now, under the radical, I have a product of the log of a plus the log of b. Okay, so that'll close the radical. That closes the denominator. Technically, I don't need this set of parentheses on the outside because this is the product, and this is already in parentheses. The parentheses don't hurt. Don't really need them, but they're not going to hurt anything, so I'm going to leave them. Okay, I'm going to write one down now, and I want you to, once it's written down, I want you to pause and then see if you can come up with the correct expansion. Okay? Okay, so go ahead, pause the computer or your video, and see if you can do the expansion, keeping in mind that there's three terms. There's an x term, a y term, and a z term. So you should have three different log expressions within this string of additions and subtractions. Okay, so there's your answer. It's the log of x plus twice the log of y minus the log of z. And again, the twice here comes from the fact that there's two of these y bases, so it's really y times y, which if you did it through expansion will be the log of y plus the log of y. They're like terms, so they combine. So you can think of it that way too. But this power comes down front as a multiplier on the log of the base. Okay, so we're going to practice more of these in class. We'll see you tomorrow.